Alrighty, today we're looking at section 10.2.1, which is going to be the fundamental counting principle. So we say, in this lesson you will learn how to count the number of outcomes for very large sample spaces, such as the lottery, the number of possible phone numbers, and the number of license plates. So for example 1, we said Nick comes across the following problem. In a 4-digit number is randomly selected from all the 4-digit numbers that can use the digits 1, 2, 3, 4, 5, 6, and 7 with repeated digits allowed. What was the probability that the selected number is 2,763? Nick knew that he had to figure out how many such numbers were possible in order to know the size of his sample space. For part A, it says Nick started to make a systematic list of the possibilities, but after a few, he gave up. What is the difficulty here in trying to create a list? So if you just think about this list, we have 4-digit numbers, and each of those can have the numbers 1 through 7 in it. It's going to be a huge list. So that's the problem. The list is huge. It's going to take a while. And it's easy to make a mistake. All right, for B, then he started with a tree diagram. What is the problem with the tree diagram? So if you think about when we did the tree diagram for even like the rock, paper, scissors, we had 3 different people playing, or 3 columns, and each one had 3, and think about how messy that got. So here we'd have 4 different columns, because it's 4 digits, and each one would have 7. So it's going to be extremely large. It's going to be very messy. So now Nick came up with another idea. It says Nick was thinking of a tree diagram when he asked himself, how many branch points will this tree have, and how many branches at each point? The problem asks for 4-digit numbers, so there are 4 decisions. So we are going to create something called a decision chart. So in this decision chart, there are like 4 columns in your flow chart. Each of those represents a decision for the digit. So that's why we have 4 lines here. 1 represents the first digit, second digit, third digit, fourth digit. And we have to think, how many possibilities would we have in that first digit slot? Well, there's 7 possible numbers. And then in the second slot, again, we could reuse a number, so we have 7. Third, we have 7, and fourth, we have 7. If you remember what we did from branch to branch in a tree diagram, we multiplied. So we were going to multiply all these numbers together. So on our calculator, we can do 7 times 7 times 7 times 7, which is the same as 7 to the 3rd power, and we would get 2,401. So that's how many total ways we can do this. So if we're finding the probability that the number is 2,763, that is only one number. 2,763 is one number out of the 2,401. So that would be our probability. For example 2, how many 4-digit numbers from 1 to 7 again, if you could not use any of the digits more than once in the 4-digit number? So now, if we're thinking about our decision chart, we still have 4 decisions to make. We still have 7 options for our first one, but now whatever we had in our first digit, we can't use in our second digit. So we have 1 less number to choose from, so there's only 6 outcomes. For the third digit, whatever we used in the first and second digits, we can't use in the third, so now we only have 5 digits remaining. And for the last digit, whatever we used in the first, second, and third digit, we can't repeat, so we only have 4 options left for that one. So if I do 7 times 6 times 5 times 4, we get 840. All right, try these 2 on your own. All right, for number 1, we have these discs 1 through 9 on them. And you're just picking the disc and not replacing it. We're trying to make 3-digit numbers, so that means we have 3 lines in our decision chart. And so I have 9 options for my first slot. But as I go to my second slot, I'm not replacing that disc. So I only have 8 left for my second. And then again, I'm not replacing any of them, so I only have 7 left for my third. So this one should be 504. And then for 2, the difference now is we have 3 separate wheels, all with 1 through 9 on it. So when I spin that first wheel to get my first digit, I have 9 options. When I go to spin the second wheel, I still have 9 options because it's a brand new wheel. And when I go to that third digit, again, it's another wheel. I still have 9 options. So if I do 9 times 9 times 9, or 9 to the third, I would get 729. And so here it says, what is the difference between numbers 1 and 2? Well, again, in this case, we can repeat the numbers for number 2, and number 1, we cannot repeat the numbers. So number 2 can get the same number twice, or more than one time, I'll say. While number 1, you cannot. You cannot repeat numbers. All right, so if we go to the second page then, it says Marco is selecting classes for next year. He plans to take English, physics, government, pre-calc, Spanish, and journalism. His school has a 6-period day, so he will have one of these classes each period. How many different schedules are possible? So if we're trying to figure out how many schedules are possible, well, the first thing is he has 6 periods in the day. So our decision chart would have 1, 2, 3, 4, 5, 6 options. So he has 6 classes that could go in first period, then 5, then 4, then 3, then 2, then 1. So if we do 6 times 5 times 4 times 3 times 2 times 1, we get 720. So there's 720 possible schedules here. The next question says, what is the probability that Marcos gets first period pre-calc? Well, even though there are 720 different possible schedules, all we really have to think about is for first period, there are 6 possibilities for first period, and pre-calc is one of them. So you don't have to make it complicated. First period pre-calc is 1/6. For the second one, it says, what's the probability that Marcos will get first period pre-calc and second period physics? So we are looking for first period pre-calc, second period physics. We know that first period pre-calc is 1/6. We just got that. Now, and remember means to multiply. And so when we go to physics, physics is 1 class out of 5 that we have remaining. Because again, if we already know pre-calc is here, he can't take pre-calc again. So this would be a 1 out of 30 probability. And again, remember there's 720 total different schedules. So like first period pre-calc, I would just have to, this is the reduced form of that. Okay, so there's still, you know, if I'm thinking here, if I did out of 720, 1/6, 720 divided by 6 is 120. So if I do, so there'd be 120 out of the 720 schedules that he had that had first period pre-calc, but that reduces to 1/6. Same thing with here. This is reducing to 1 out of 30. We're just looking for the probability. All right, so then it says on your calculator, you can find the label N. Oh, exclamation! I gotta be excited, right? All right, so on many graphing calculators, you can find this button, the excited button, we'll call it, under the math menu and then the probability submenu. And this is actually called factorial. You can scream it if you want, though. Factorial! All right, so where do you find this? If you go to your calculator, you press the math button, which is right here. Okay, so if we press math, scroll to the right until you get the probability. And then right here, it's an excited 4. 4! It's like it's playing golf. Okay, so for the first one, It says find the value of 8 factorial. So again, the way we would do this is we'd press the 8 in here first, press the math button, scroll over to the probability, press 4, and we get 40,320. All right, so then go ahead and write down, figure out all these other ones. All right, so you can see as we go through here, those are all of our options for the different factorials. Part B says, which result is the same as the number of Markov's possible schedules? Well, if we look up here, we said there was 720 schedules. 720 is right here at 6 factorial. And that makes sense because remember, factorial means you start with that number, it's every number less than it. So here, we had 6 times 5 times 4 times 3 times 2 times 1, 720. So that's what factorial really means. You're starting with that number and it's multiplied by every number less than it. So what does 6 factorial mean? Again, 6 factorial is going to be 6 times 5 times 4 times 3 times 2 times 1. All right. And why does that give the correct solutions for the possible ways to arrange Markov's schedule? Because again, he could have 6 classes first, then we're not going to retake it, so 5, and then 4, then 3, then 2, then 1. Part D says explain why 4 gives the correct solution to the possible number of ways to arrange the letters math. Well, again, if we think here, well, there's 4 letters in math. There's 4 different possible choices or letters that go in the first spot. Then we can't reuse because there's no reusing of letters. They're all different letters. So only 3 would be left for the second, and then 2, and then 1. And by definition, that is the definition of factorial. 4 times 3 times 2 times 1. Starting with that number and multiplied by every number less than it until you get to 1. And again, that would be 24. All right, the last thing we're going to look at is how do we simplify these factorials? So remembering what n factorial means can help you do some messy calculations quickly, as well as help you do problems that might be too large for your calculator's memory. For instance, if you want to calculate 9 factorial divided by 6 factorial, you could use the factorial button on your calculator, and we could type in 9 factorial. 9 factorial is 362,880. We can type in 6 factorial, which is 720. So therefore, we could do 362,880 divided by 720 and get 504. But an easier way you can do it, and you can probably do this one without a calculator, is you can write the factorials out and then cancel. So remember, 9 factorial is going to be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 6 factorial is going to mean 6 times 5 times 4 times 3 times 2 times 1. And since these are all separated by multiplication, things cancel out. The same number, or we can reduce. So in this case, 6 cancels with 6, 5 with 5, 4 cancels with 4, 3 with 3, 2 with 2, and 1 with 1. And so after all this canceling, we're really just left with 9 times 8 times 7 over 1, which is much easier to work with. 9 times 8 times 7 is 504. So when it states to reduce or simplify the radicals, that's what you're going to do. So looking at a couple examples here, use the simplification technique above to simplify each of the following problems before computing the result. For 10 factorial, again, we'd have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So all of these are going to cancel out. And I'm left with just 10 times 9, which is 90. Which is much easy to do. Very easy to do without a calculator. Now, that was still a decent amount of writing. So the shortcut here we can do is, for B, we have 20 factorial. That'd be a lot of writing. So I'm going to write 20 times 19 times 18 times 17 times ... all the way down to 1. So 18 factorial would be 18 times 17 times 16, 15, 14, all the way down. So ... all the way down to 1. Now we have times another 2 factorial. So I'm going to put times 2 times 1. But what's going to happen here is this whole 18, 17, 16, all the way down to 1, that's all going to cancel. So all those cancel. So I'm really just left with here is 20 times 19 divided by 2 times 1. And before I actually do this multiplication, I can even reduce this further. Because although they're not the same number, I can reduce this fraction. 20 divided by 2 would reduce to 10 over 1. So now I'm really just multiplying 10 times 19, which is 190. And dividing it by 1, which is still 190. All right, try C and D on your own. All right, for C, 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1, and then times 3 times 2 times 1. And so it doesn't matter which ones you're canceling out, but a 3 is going to cancel with 3, a 2 and a 2, and a 1 and a 1, and then the 4 is going to cancel. Also, what you can notice here, 3 times 2 is 6, and I have a 6 up here. So the 6 is going to cancel with the 3 and the 2. So after all that's said and done, I have 3 times 5 over 1, which is just 35. For letter D, 75 times 74 times 73 times 72 times 71, ... all the way down to 1. And again, 72 factorial would be 72 times 71, ... all the way down to 1. So what we're going to get is canceling out and be left with just 75 times 74 times 73, which would be 405,150. All right, now you know what factorial means!